Hey everyone, this is just another addendum to video, I believe, number 37. I'm going to double check that. I want to make sure that's correct. Yeah, number 37, where we switch the limits of integration. And essentially, I'm just going to do another problem. And so we can really hammer this in, and you know how to switch the limits or switch the order of integration correctly. So this is the problem. It's simply given evaluate this double integral. It's from a previous final, from 10 years ago at this point almost. Wow, 2009, 10 years ago, damn. Anyways, so how do we approach these problems? Well, if you're just given this on an exam, right, how do you know this is a switch the limit of integral type? Well, the answer is, if you're given a double integral, if it's not polar, it's switch the limits. And in this case, why is it not polar? Well, the bounds here don't really tell me if it's going to be polar or not. Or if it's going to be like a circular region, right? Those look like straight lines. And then this guy in here, well, there's no x squared plus y squared term, which means I'm not going to get like r squared, which means then I'm not going to use polar, okay? So, yeah. Then how do we do this problem? Well, first step, again, is to draw the region, right? So, okay. X is my inside integral. That means this first guy down here, this first integral, has x equals 2y and x equals 4. I know what x equals 4 looks like, right? And x equals 2y, well, if you divide both sides by 2, that's the same thing as saying 1/2 x is equal to y. And we all know what that looks like, too. It's this guy with slope 1/2. Okay? Oh, whoa. I actually gave it away. Well, not really. This is x is equal to 4. And this guy is x is equal to 2y, which we also wrote as y is equal to 1/2 x. I'm on the corner of my screen. Oh boy. Okay. So now what? Okay, so that's going to be my bounds, and then I got 0. I got y is equal to 0, which is this guy down here. I got y is equal to 2, which is that guy up there. And now I need to know if I'm this top rectangle or this bottom rectangle. Well, I'm going to be this bottom rectangle, right? Because dx tells me if I draw a line through my region, I need to hit the slanted line first, right? And that's exactly what happens if it's the bottom rectangle. I'm going to hit the slanted line right here first, and then enter my region, and then exit when I hit x is equal to 4, right? And that's the vertical line. Cool. So bottom rectangle is going to be my region. And now I want to switch the limits of integration. So now I want to do, okay, this is negative e to x over 2 dy dx. And now what happens? Well, now dy is my interior integral, right? That means my integrand on the inside integrand, the limits are going to be y equals something and y equals something. And to figure out what those are going to be, I need to draw a line through my region parallel to this y-axis right here, right? So, okay, let's do that. Then I draw a line parallel through my region parallel to the y-axis. And what happened? Well, I hit that guy, enter my region, and then I hit the slanted line. So, okay, I hit this bottom line first. Well, that's easy. That's y equals 0. So, y equals 0. And then I hit the slanted line. But the slanted line was given to me originally as x is equal to 2y. But of course, I can just convert it into y is equal to 1/2 x. And then I get y is equal to something. So after hitting the slanted line right here, right, we know that that's y is equal to 1/2 x. So hit 0, enter my region, leave at 1/2 x. Okay, so that's going to be my bounds on y. And I'm going to erase the y equals. Actually, let's just leave those guys. There's no hurt. And then now what? Now I need to figure out my x bounds. Well, my x bounds are just going to be where's my minimum x value and where's my maximum x value. And you can just see the minimum x value is going to be here at the origin, and the maximum x value is going to be along this line. X is equal to 4. So the minimum x value is going to be 0, and my maximum x value is going to be 4. All right, now I have this double integral I need to integrate. So let's integrate with respect to y first. And since there's no y on the inside, I can just essentially bring these guys down. So I get 1/2 x times e to the negative x squared over 2 dx. So I integrated with respect to y already. And then now we need to make a u sub. So let's say u is equal to, negative x over 2. And du is then negative x dx. So I need to get a negative x in this inside here. And how to do that? Well, it looks like I need to multiply by negative 2, which means I need to multiply by negative 1/2 on the outside. Okay. So now I get negative 1/2 the integral of, okay, this is negative x, right, if you multiply that, dx. So negative x dx is du. And then I have e to the negative x over 2, which we said was u. All right. And then for the bounds, what do I need to do for the bounds? Well, I need to plug 0 and 4 into this equation right here, right? So, and I just erased an axis on accident, all right? So, 0 plugged into this equation is 0 squared, which gets me 0, right? And 4 plugged into this equation is 4 squared is just 16, divided by 2 is 8, and then take the negative, so negative 8, right? And now what? Now what's wrong here? And let's make that a more prominent negative sign. What's wrong here is that the negative number, right, the smaller number is on top, which means then we flip the order of integration. So I get negative 8 on the bottom, 0, and this negative 1/2 becomes a positive 1/2 because when you flip the top and the bottom, you need to multiply by negative 1, and this is still e to u du. And this makes for a pretty easy integral now because it's just e to the u evaluated from negative 8 to 0. And what do I get? I get 1/2 times e to the 0 minus e to the negative 8, which is actually 1 minus e to the negative 8 over 2, right? E to the 0 is equal to 1, okay? So that's another then example of switching the bounds on integration. And yeah, this is a really common problem. You see it's on a previous final. This picture is the biggest thing you're going to need to do. You're going to need to know how to draw this region and then switch the limits. And yeah, that's just another example. Hopefully this was helpful. And that's it for this section.